Hey folks, I'm Joey Pickardt, German audio engineer and guitar player, and welcome to my video series building up a modern metal tube amplifier. This time it's part 5, so we've done a bit, but we're not quite in practical stuff, and this I'm going to change today. So in the last videos we talked a lot about the theory, about schematics and how the things should work together, but today it's finally time to put the parts on the chassis and start building up the amplifier. I think this is a very important step because you are dealing with some issues in placement of parts. I think you are influencing the sound of an amplifier. If you place a part wrong, you will have to deal with feedback or with other disturbance into your sound. For example, it's a bad idea to place the very first tube of a high gain amplifier nearby the power transformer. What would happen? You will get a lot of hum problems, a lot of 50 or 60 hertz into your signal chain, and you won't be happy with that. You can use a noise gate, but it's all over the place, this hum. I tried it, it's not a good idea. So you need a bit of experience how to place the part, and I have not that much experience, but quite a bit, and I think I've come up with a pretty good layout, and let's have a look together and I tell you something about that in detail. So here we can see the aluminium chassis with the parts just placed on top. We can see the preamp tubes at front, the small shielded ones. At the left we can see the big power transformator. Nearby the power transformator there is the filter capacitor and the filter choke, and then the power tubes, and at the right we have the output transformer. Okay, the very first input preamp tube will be at the left, and then the signal chain will flow through the 5 tubes until we reach the phase inverter and the signal goes into the power tubes. So this I think is a good layout. The inside is like this. Worth mention that there is missing the 5th preamp tube socket. I can't place it in there, but you can see the big turret board on the left for the power supply and the other smaller ones for placing all the preamp and power amp signal parts. If you start now placing this on the aluminium chassis, you need to get all the diameters of the parts to drill the holes. For that I've overtaken it on paper and drawn all the diameters and the right sizes point to point, and the next step is now to overtake it into a CAD program and to print it out, to glue it on the chassis top or just stick it to the chassis top, that you can drill all those holes and know the right diameter while you are drilling. So this is my plan for this aluminium chassis, so I don't have to draw all those holes like you see it over there. Okay, I've overtaken all the measured diameters from my paper into the digital world. I've used Target, the front plate designer of Target, to do this, and you can see I have here a layout, a template that I can print out, which is including all the diameters from the top of the chassis. On the right the output transformer, on the left the power transformer, up here the output tubes, the holes for the capacitor, it is the big JJ capacitor I want to put on top. Then the filter choke is placed here in the middle, and down the preamp or the small 12AX7 tubes. And This now I can print out and lay on my aluminium chassis and start drilling. And after a lot of drilling, the top is finished and can take care of all the parts, but I can't mount them yet because I have to do the same procedure for the front and the back panel, and this is taking, I think, quite a time until I have a template like for the top. And within a few seconds I have prepared something for you. This is the front layout, and it took, of course, longer than a few seconds, a few hours maybe, but I'm not quite happy now with it because the power switches and the power lamp are not fitting. They are fitting at the front, but not with their diameters and dimensions at the backside into the chassis. So maybe I place the power transformer, the power switches on the backside of the amp, like in fenders, because this big chunk is a problem within the power lamp, and if I move the switches to the left a bit, then I can't place a logo there, and I want to place a logo. Maybe not this logo at the end, but some logo. So I don't know, it's not finished. I don't drill that one, but I'm working on it. And I've finished the design of the front and the back panel. Let's have a look together. The switches have moved to the back side, so I have a clean finish at the front here and enough place to put a logo at the front. Let's have a quick view into the placement of everything. Up and down is mainly the same. It's up on the top, it's the lead channel, and down at the bottom it's the clean channel. The lead channel in addition has the regulation of the noise gate plus a switch to turn on and off the noise gate, and down here in the line with the clean channel I have my input jack, and the rest is nearly the same. I have two switches for the voicing of the channels, equalizer, presence, master channel volume and indicator lights, and a master output volume after the FX loop, and also the indicator light. That's all for the front. Let's now have a look at the back panel. Here we are. And on the left I have my input jack for the AC power wire, two fuse holders for the heater fuses and the high voltage fuse, and the both power switches, power and standby switch. It's nice to have it at the back because all the leads from the power transformer can be very short and are not moving that far into my amp and are not coming in the near of some signal amplification, so maybe I have less noise from AC 50 Hz signals into my audio circuit. On the right we can see the reverb regulation for both channels, and a feature that I'm putting in is a volume boost on the lead channel with activating or deactivating the reverb, so I can use it like a solo boost function. The foot switch jack is down here, and the tip is will be changing the channel, and the ring will be activating that solo boost function. Here is the FX loop input and output section, or send and return section, and a negative feedback on-off switch, so I can cut off a negative feedback that I'm putting in from the power tube to the phase inverter. And last but not least, down here I have my speaker output jacks placed. I didn't place a 4 ohm output jack. I don't need it. I never needed it on any other amplifier. It's pretty uncommon that you have a cap that has 4 ohm. It happens, but mainly you have 16 or 8 ohm versions. And I think that's a nice design, and I can start drilling again and then finally put on the whole parts and start to have that feeling that this is going to be an amplifier. Okay, from here on I have captured a lot of the work in time-lapse, and while we watched it I give you some information. if you see what you see here is I'm using a lot of drill holes to get out that rectangle shape from the AC plug. If you know better way to do that, then please tell me. It's always an annoying step of work to get this squared form into the aluminium. For all the holes I used a step drill. I know a set of punches would be nicer, would be produce nicer holes, but I only have that step drill and punches are quite expensive, so I can live with it. And if you use a file after that and make sure everything is not sharp anymore when you are finished, then it's okay and you can place your parts, and after you placed your parts you won't see it anymore. So finally the holes are all drilled and we are ready to start mounting all the parts. I have to be honest, this is the second chassis I'm building because I totally screwed up at the first one. So as you can see at the comparison of the drill holes, I totally screwed up with this one. Because the top is like it's the same, but the front and the rear panel are on the head. I don't know when it happened, but that's how it is. So I can't use it. Maybe I use it later for testing or something, but it's not for now. So after this pain in the ass, I hopefully can work normally again forward. So after this big mistake, it was a good feeling to finally place some parts on the top. I mean, after ordering a second chassis, spending money for that and drilling all those holes again, it was a bit frustrating, but after this now I'm back on track and it feels good that the amplifier is finally getting a face. And it is quite a nice moment when you have placed all the parts and they are mounted and your project is finally turning into something real. This is quite giving you a boost of energy, but it is still a lot of work left. So the next would be the wiring. Okay, at first for the wiring you start with the power jack because it's the first thing that has to be mounted good and grounded good. And as you can see, after that I placed the power switch and attached the output jacks because they're down under another board, and then I cared about the JJ capacitor and all the grounding spots at first, and after that I cared about the fuse holders and the turret boards for the power supply parts, because this all has to fit in this right corner, and it's pretty important to use good star grounding points so you don't have to bother with any grounding problems, humming or something like this. You won't get this small potential differences in this chassis, so use star points for grounding. And then you can see here how I place all the parts for the power supply, and now it's time to turn it finally on at the first time. On, because I have this switch between it, and I put the cord inside. Okay, and now let's have a look what happens. Maybe it's getting dark in a second here, I don't know. We'll find out, or I blow everything off. 3, 2, 1, go. Nice. I see the pilot light is glowing and it's looking very nice. Okay. High power voltage is off. So just let's have a look on the voltage for the heaters, the DC side. That's not looking good, actually. Here we go. 7.29 volts. It's pretty high because I don't have any heaters connected, except the pilot light. Okay, and the rest is, at this moment, AC, I think. Now, let's have a look at the high voltage. It's not connected to the capacitor now, because the switch doesn't switch. Well, we should get here, over here. 632 volts. Okay, that's pretty high, but I expected that. Now the great moment has come. I have to turn on this switch. Here we go. Okay, let's have a look what we have now. 443 volts. What I did not show in the last measurement video is that I also measured the biasing voltage, and it turned out that two resistors are too small and I'm only getting minus 20 volts, so I changed the resistor values to higher ones and I end up with minus 60 volts, which is a nice voltage to start for the bias, and so I left it like this until I have to bias the tubes, and I hope they can stay like this. What we can see now in the time-lapse is the power amplifier board with two potentiometers. We're going to have a look in the seconds on this closer, but I'm also installing here the primary winding of the output transformer on the anodes of the power tubes, and the white one is the high voltage connection, the center tap. I decided to get two potentiometers to symmetricalize the biasing of the power tubes. I really like the idea. I have done it in an amp before, and I'll show you on the schematics how it works. These two pots are going to be connected to my bias supply here. Actually here or here maybe, there where the volume, the voltage is better for biasing. And then when I'm finished, it's going to look like this. So I'm getting in the bias and going into the pots for each tube. Then I'm using a 220K to separate the signal path from the phase inverter from my bias supply. And because here is not really a big current flowing, it's okay to use that high resistance. It's not a problem for the voltage, for the negative bias voltage, because this is only the gate. There's barely current flowing, and from this side we have two capacitors in the phase inverter that are blocking every direct current, DC voltage. So this will work, and this one is for protecting me to getting too far to 0 volt, because the gate will deliver get too close to low volt from 0 voltage, from low negative voltages, and it would flow too much current. And as you can see here, I decided to put some cathode resistors for biasing measurement in the amp, because I have a measurement tool, but this way it's shorter and it's not really a problem with 1 ohm for the rest of the sound. Now it's time for the first bias adjustment, but my camera didn't work, so I show you what I've done on the schematics and we have a look at the actual values later. At first I connected my multimeter between those 1 ohm resistors between cathode and ground, and because they have 1 ohm, the result of the millivolts of the voltage drops are representing our milliamps that are flowing through the tubes. After that I take care of the potentiometers that are turned totally up, and the negative biasing voltage is maximum at the gates so that the tubes are closed before I turn on the high voltage and no current can flow. After that I turned on the high voltage part at the anodes and measured around 400 volts at the anode voltage. Then I looked up the value that is good for a 5881 for biasing in milliamps at 400 volt, and it is around 40 milliamps for 70 volt percent plate dissipation. So I turned up the potentiometers and configured this value on. Okay, 42 millivolts. I've switched over to the second tube and let's watch the bias current here. .43. So this pair was delivered matched, and it is power supply voltage 400 volts. With the measured values we can now calculate the plate dissipation of the tube to make sure it is operating inside the specs. We have 405 volts of anode voltage and 43 milliamps of current flowing, which is delivering 17.4 watts of plate dissipation. The tube can handle up to 26 watts of plate dissipation, so we are around 70% of the maximum, which is a nice and warm biasing and typical for guitar tube amps. So I start with that, and if I don't like the sound or operation is problematically because the tube is getting too hot or something like this, I turn it down a bit. Now something completely different. I'm mounting the potentiometers at the front because I want to mount the boards for the preamp and the phase inverter, but I can't mount them before I mount the potentiometers because there's less space in the chassis and it won't fit after. Now you can see how I'm installing the preamp heater connection, and it is not drilled because I'm using a DC voltage to heat the heaters at the preamp to reduce hum. The cap that is installed, you can see, is the phase inverter here, the yellow one. And here you can see how I'm testing the channel switching relay function. So the amp is getting more and more functional. You can see the indicator light between lead and clean channel here. After that, on the left side, I'm working at the very first input parts. So I'm placing 1 or 2 resistors and connecting the very first 2 triodes. And here's a small jump in the time stretch video, but now you can hear some tunes hopefully in the next video. Okay, the first 2 triodes of the preamp are finished. So my clean channel from sound is ready. The equalizer is not built up yet, but the first 2 triodes, as you can see with the camera up here, is finished. And I've connected both master volume, but the gains are the separate gains settings and equalizings for the preamp that I'm going to use on the actual complete amp. So we can make our first sound check. Where's the volume down? I also upgraded my later chassis with a vintage 30 Celestion speaker, as you can see. Clean channel, and there. Reverb. Yeah, got reverb. Both humbuckers. Oh, for information, I'm playing just a test guitar. This Gain Deluxe Elan. It's pretty much built up like standard Ibanez, or every Fender with humbuckers to split coil and switch between it with a three-way switch. I'm playing both humbuckers on both coils selected. It's working. Just the bridge. Just the neck. I like it. We're about at 11 o'clock in the game, but we get a slightly break up in sound. I don't know how good the camera microphones are working, so I'm going down in the volume when I push it, and then I push a bit harder. You can see the distortion. Here the distortion. I take the reverb away for clean. Bit more gain, 13 or 1 o'clock. Okay. 3 o'clock. And completely driven up. Okay, it's pretty that gain that I maximum would have expected from a clean channel. So that's everything for today. I hope you had fun watching. If you had, then hit the like button or subscribe. If you want me to go into more detail in something, then let me know in the comments, and everything else will be explained in the next videos. Have a nice day. Bye.